that alone has some challenges, as you can well imagine. Just for information, this is how our facility is staffed. We have multiple facilities we take care of, but we've got one manager, some level 3 operators, a large contingent of level 2 operators here in the green, 4 millwrights and mechanics, 4 electrical instrument techs, 1 laboratory tech, and 1 source control tech. Okay, I'm going to zip over right to the video because I need to play those first before I get into my story. And when I get into my story, if you got any solutions for me, I sure would be glad to listen because we're a little bit stumped right now. Okay, I'm going to share my video. It says everything should be good. Okay, so I'm going to start the video. Hopefully it goes good.
7 days a week, 24 hours a day, 365 days a year. There is no other option for the city of Kelowna. This treatment plant has to run, and it has to run 24 hours a day. Right now we're processing approximately 37 million liters a day of wastewater, treating that to near drinking water quality standards before it discharges to Okanagan Lake. Everything flows as much by gravity as we can. Comes in and we do some rough screening on the front end to remove some heavy solids or wood or rags, that type of thing. And then directly to our bioreactors where we provide an environment for the microorganisms to live. So we inject air into the water. They already have food from the wastewater. And the organisms live and grow and reproduce and eat what's in the wastewater. And from the secondary clarifiers through ultraviolet treatment, and then discharges to Okanagan Lake. Our process control systems are SCADA systems, which is basically computers talking to what's going on in the plant and then displaying that graphically. We run fiber optic networks around the plant. Everything at the plant has a backup for redundancy purposes, again, because we can't be down, and it's pretty cool and very technical.
We have our primary effluent diversion pumps. Our effluent coming in gets recycled 500 times within the same cycle. We have saturation tanks that float to all of the sludge to the top that gets skimmed off. And everything that gets skimmed off goes back to the head of the plant.
I'm very proud of this facility. I'm proud of the people that work here. We have a very highly trained, dedicated staff. And as a team, they work very, very well together.
We have pumps, we have grinders, we have motors, we have hydraulic systems, we have conveyor systems, we have belt drive systems. So anything that breaks down or needs to be modified, we'll come into this shop. We try to have a plan, have the parts here. Most everything we try to do is preventative. There are a lot of pieces that are running here. This entire plant, all the buildings are under a vacuum.
It's a vacuum that pulls from every part of the plant, and this is what prevents any odor going into the community around us.
What we are is environmental stewards, because what we treat here goes back to our lake, and we cannot have it not up to standard. It's not an option. Very happy with the staff here. I can delegate any job to any of the millwrights, and the electricians are awesome. They'll jump in and help out. Operations, same thing. Like, everybody will help everybody here. When you see what comes into the plant and what leaves the plant, I'm actually really proud of that.
Okay, that's.
I might just mention, Mike, that you have worked in St. Lucia and you're familiar with things, so you do know that that's not what all of their plants look like in the Caribbean.
No, that's true. A lot of that all takes time and money, right? I'm not going to go ahead and show the other short video. Just, it covers a lot of the same background, but it talked more about the upgrade that we recently went through. Well, we can, I think we've covered enough of it that I can get on with my story for today. So, I'm sorry, I got to bounce around screen, so you got to bear with me. I'm just going to share this screen. Here we go. So the reason that we did an upgrade we started the upgrade in 07 and then completed it in about 010 or 2010 was our influent. We started planning around 2003, and you can see our influence spike, the blue line here, started going up. More and more people moving the community, so we're like, okay, the influence going up. It takes decades and years of planning to get money and do upgrades to facilities. Then our flow kind of leveled off, but then it started to rise again. So we're like, yeah, okay, we need to move forward with this upgrade. Right around 2007, it kind of leveled off. We had a flow correction here on some of our equipment, and then the flow came up, but they did not shoot up as high as we thought they were going to. When we were running our plant prior to the upgrade, we were running at about 85 to 95% capacity. So again, that graph that shows you why we went ahead and started that upgrade. We also had a lot of equipment that was at the end of its life, so it needed to be replaced as well. So I just have to find my picture, so bear with me. I've got 2 monitors. I need like 4 to get it all straightened out. So as part of our upgrade, we new bioreactors and secondary clarifiers, a whole bunch of other equipment, but my main focus of this chat is about bioreactors and secondary clarifiers. Our flow leveled off to about 50% capacity of the plant. But our loading is somewhere around 85 to 90% of the plant capacity. So
7 days.
when you look, if you remember the video, and maybe I'll pop up that picture just for a second. We have, for the amount of bioreactors in service to manage the flow, we're overloading them with solids coming in the facility. So the number of the reactors in service by flow, we tried to combat that by having some higher solids in retention to deal with the nitrogen and phosphorus. But what we found out then is during the higher diurnal flows, we were actually pushing solids out the back of the plant and onto our filters. So that was causing us some grief. And it worked, but it didn't work as well as we wanted it to. So then when we tried the approach of putting a number of bioreactors in service by the amount of loading that comes in. So we increased the number of bioreactors. I'll share the screen without the video. So we increased the number of bioreactors in service. But what that wound up doing is our secondary clarifiers at certain times of the day during low diurnal flows, they're becoming stagnant. We were having no flow out of the secondary clarifiers, which then gave us some phosphorus issues we were dealing with. We were dealing with low flows in the plant in our bioreactors, so we're over aerating, which gave us some settability issues in our secondary clarifiers as well. And also with that, sludge age. Our sludge age was beginning to get way too long, and we were having secondary phosphorus release throughout the whole facility. And our phosphorus permit is 0.25 milligrams per liter. So let's stop the share. There we go. So the best of our understanding was the population was still increasing slowly, but why were our solids continuing to rise? Like I said, we leveled off at about a 55% capacity for this treatment facility, and our solids were 85 to 90%. So theoretically, we should be planning for our next facility upgrade here, and I only have 50% of my equipment in service. So our first target that we did some research on was wineries and microbreweries, because they typically have lower effluent flows, but they have a very large source of BOD and COD in their effluent. Before we dove into exploring that, we thought for sure that's where the problem came from. But that actually only turned out to be a small part of the issue. The larger issue, which we're still investigating, so I can't comment on it 100%, but it seems now that our community has taken a strong approach to low flow fixtures and water reduction and reducing consumption. But that low flow fixtures and water reduction has seemed to have an adverse effect on the treatment facility. So we have an engineering firm, we're looking into that, seeing exactly, we want to quantify those numbers. To help combat some of the current flow and load issues we're having, we've increased some of our operations workload. We're monitoring and testing solids throughout the day. We're monitoring and adjusting reactor flows to balance, balance that as much as possible. And we're consistently making challenges or changes through the day. So we have operations staff that could or should be out doing something else, and they're constantly testing and making adjustments that you might need an adjustment every day or two, but now we're making several in a day. We've had some positive results. We've been able to maintain our effluent quality, which has been good. And we're going to look at incorporating some of those changes into our control system so the control system could take a little bit of workload off the operators and make some of those changes over 24 hours a day. So, we need to look to the future to kind of combat this issue. If the population continues to rise, we're obviously going to have more flow and load coming to the plant, but the loading situation is far outweighing the flow situation. So that will basically put us over the top, and it's going to have some dramatic or drastic effects on our effluent quality if we can't get a handle on this. Like I said, right now we've managed to operate the facility. It's operating really well, but our loading capacity is close to max. In a nutshell, that was about it. I was hoping we could have some Q&A time. Any questions or thoughts or comments? Because I'm definitely open to any experience that anybody's had or anything even close to what we're dealing with.
Mike, we just
Hi, when you
had two
sorry,
people join us, so perhaps you could just very
Yeah.
quickly summarize what the problem has been, and a little bit on that. Just summarize it really quickly.
Okay, sure. So in summary, our facility is running at 50% capacity of maximum flow, and we're running at 85 to 95% capacity on loading. So as the population increases and the flow goes up, the loading is going to go up, but it's not comparable with what you'd see normal loading increases. So that loading increase could, unless it's dealt with, that loading increase could put us out of compliance as far as what the facility will be able to handle. Okay, Nicole, sorry.
hi, when you mentioned the conditions, I thought about how a sewer system would be affected due to drought. So you want to have that much water coming through the taps at the home, so therefore leaving the wastewater going into the sewer system will give as you said, low flows and a high influence strength. So what about flushing in certain zones that have in certain zones within these network to help bring water to help dilute the strength that is coming in? Or you said that you're experiencing spring now. I don't know about snow melt. Will that help too? I'm just trying to
Yeah,
think.
no, some great thoughts, Nicole. So for us, we're a 100% separated sewer system, so the snow melt won't help. There's part of me that wishes we were not 100% separated, because it would ease that a little bit. We started doing some flushing in outlying areas of the city, because we've been dealing with some odor concerns, and we may need to increase that flushing component. The problem for me is the only water for us to flush with is treated potable water. That's the only thing available to us. So for me to use potable water just to dump it back down the sewer system, it's something that I personally really don't like. But
I understand.
but what do you do? You're absolutely right. Sooner or later you need to find some kind of solution. And and with that higher solids content and lower flow, that is having an impact on the odors in our sewer system as well. So good points there. Good thoughts. Thanks.
Are there other questions or maybe potential solutions from anybody? Because otherwise I'm going to ask Mike to comment on a couple of other things from the plant.
Good day.
Hi.
Hi. You say they want to use any potable water, but a thought came to mind. I'm not sure with what Nicole said. What do you happen to have any old wells or abandoned well fields that are not used, that can't be used for, let's say, treatment standards, that they might have maybe too high iron or manganese inside, that can at least help to alleviate the situation with the water being concentrated? That I just thought about this. I'm not sure how well that might work, but since you don't want to use potable water, which you can understand, that's not technically potable since you just have to pump it out.
Well, that's interesting as well. We don't really have any wells that would produce excuse me, a volume of water that would be beneficial, but now that you mentioned it, I guess we do have several creeks going through town, and if I couple that with Nicole's comment, we will be having some freshet runoff soon, and there's going to be an abundance of water in those creeks. So maybe pumping it out of there into some kind of manhole that wasn't too far away might help that situation too. It would alleviate a little bit of water going down the creeks and keep our systems flushed out a little more without using potable water. Because using that potable water just gives me nightmares. But that's good. That's a good thought. Thanks.
Any other questions, suggestions? Okay, Mike, could you, you have got a terrific composting facility. What percentage are you, sending to, what percentage of the wastewater do you actually use? And could you talk a little bit about what you're doing in that respect?
As far as composting, for sure. Just bear with me 1 second. I'm just trying to look at my other video has just a little bit on compost. So if I can play that would help. This is help answer those questions. So bear with me and I'll share my screen. And then I'll answer your question. How's that?
Then composted with wood chips and sold as overgrow. An excellent fertilizer that is available to residents and businesses. After the wastewater makes it through the secondary clarifiers and UV disinfection, it is pumped into Okanagan Lake at a depth of more than 65 meters. At this point, the water is nearly drinking water quality, which is a good thing since the lake is our main drinking water source. As the city looks at ways to improve our process and protect our main water source, the community can also do a lot to reduce the demand on our system.
So it touched on our biosolids a little bit. We are trucking about 2.5 semi loads a day to the biosolids facility. Sorry, I got sore throat today. Biosolids facility, about 18,000 kilograms per semi-load, 16 to 18,000 at about 20% solids that we transport to our biosolids facility. Did that answer your question, Val?
Yeah,
or-
but can you tell us a little bit about that process?
Oh, okay. Yeah, so when the biosolids facility, they take loads from Kelowna and Vernon. Vernon is a neighboring community. They mix it with wood chips or hog fuel. It then gets stored in windrows, and we add air to those. Sometimes a little bit of heat in the winter if needed. That air is very similar to a wastewater treatment facility. You add air to your bioreactors, it increases the ability for the growth of microorganisms. And the same thing at the biosolids facility. Promotes decomposition. It sits there for, I think it's a 45-day turnaround. And then we produce Class A biosolids from there that it's either sold to the public or sold to a lot of larger landscaping companies that repackage it and sell that material.
So what sort of standards do you have to have with that? Who makes those standards to make sure that that's safe?
Yeah, the standards are all issued by the Ministry of Environment, which monitors all activities for wastewater treatment facilities, biosolids, composting, all that kind of activity. They would be considered very similar to, well, there are licensing and certification monitoring unit for the province of BC.
Okay.
I was trying to remember, what's the USA? EPA, that's what I was looking for. Yeah. They'd be similar to reporting to EPA in the States.
And the other thing, I mean, it's a while since I've been in the plant there, but you do a lot of energy recapture, do you not? And you supply energy to some of the local schools and put it back on the grid?
Not so much energy right now. We're looking at, we're in the middle of reviewing, creating or constructing some digesters, which will then produce power for the facility and then put back on the grid. Which will be nice, but that's probably a few years out. Digesters facilities can be expensive to build and nobody wants them in their backyard. So there's a public issue with that for sure. What we do though, is our effluent is piped through heat exchangers at the college and the high school that I mentioned at the beginning. And their heat exchangers draw heat off the water, and then it makes a loop right back into our effluent line. It goes out to the lake. So they are reducing our effluent temperature, which is great for receiving body water, and they're dramatically reducing their energy consumption by using heat from those heat exchangers. And we are you can start with by September in the early evenings all the way through to April that you would be drawing heat to heat schools from. So there's, like I said, dramatic decrease in their consumption of energy. On site, we do a lot of energy management, try and get the latest equipment to reduce our energy or our carbon footprint. We deal a lot with Fortis Power, Fortis Gas, which supply our gas and power, and they have a lot of rebate systems to help us do studies or get equipment and implement that equipment. It's actually kind of, I find it very interesting because they'll give me money to do an energy study. then they'll fund the project or a large portion of it, and then they give me money back, and then I get to put it into another project. So I know it works really well for them, but it's really nice for us too to stay on top of things and try and get some of the latest, greatest equipment that's energy efficient.
And talking of equipment, a few years ago, I remember you put in a new centrifuge. And we always like to hear about problems and how they came about and what the solutions were. Can you tell us a little bit about, putting in that new centrifuge and what were the problems and how did you overcome them, Mike?
Well, let me back up the story just a little bit. So we had a Sharple centrifuge, and it doesn't matter about the brand name, but this centrifuge ran really fine for us. It was good. We were probably running that 12 hours a day. So in the upgrade previous to the one I mentioned, said, well, we need a backup centrifuge. So we need another centrifuge. And somewhere along the engineering documents got confused or some numbers got transposed. We wound up with this little baby centrifuge that was like 1/3 the size of the one we had, which would have worked really well based on their calculations that it was supposed to run 24 hours a day, not 12. So then we roll the clock forward to our next centrifuge, and we wound up with a mammoth version of centrifuge, and it works really, really well. It's the throughput for the solids handling that we're having to deal now is fantastic. Some of the challenges we have had with those, it's a great centrifuge. I have no complaints with it whatsoever. But we're stocking after one breakdown and a bearing failure and finding out it was 6 months to get bearings and some other parts. We're now stocking a lot of parts on site because they have to come from overseas and they are a long lead time. That was pre-COVID. Lead times are probably, that same bearing is probably 18 months away now. And without, as you know, from running your own facilities, without removing those solids, you can't operate the treatment facility.
So, but it's all running well now.
It's, don't jinx me, Valerie. knock on wood, it's all good.
And one of the things that when I look at the videos, everything looks brand new, but it's not really brand new. It's just because you have a very strict operations and maintenance program. Can you talk to us a little bit about that? Because in the Caribbean, very often an O&M program is, I won't say non-existent, but we tend to put out more fires, as you know. So talk to us a little bit about your operations and maintenance, that what that looks like.
Yeah, we have a very stringent O&M program for sure. We generate work orders that are assigned to staff. We upgraded our system and we incorporated that into time cards as well. So in order to get paid, their time card is linked to that work order. And it wasn't to monitor X employee spent so many hours doing a job. It was more so we could quantify and validate the equipment that we have, when we need replacements, what work has to be done, and that type of thing. And it took a little while to get everybody on board, but it's sure proven to be beneficial. As far as our O&M program goes, we said it's very stringent. We have our raw pumps for our facility, for example, are 20 years past their lifetime, and they look brand new. They operate within brand new specs. So for us, annually, we'll take one of those apart. We'll refurbish bearings. We'll check blue clearances, that type of thing, and keep them in service. What that does for us, I feel as well, is it keeps our level of redundancy in place, so we're not always, like you said, putting out fires or having to do something else. There is a cost to having a good O&M program, but when we do the numbers, that cost is far less than emergency repairs and having to replace equipment.
Super. Hey, And we're getting up near the top of the hour, but are there any questions on anything to do with the plant that Mike's talking about, or challenges that you've had that might be similar or different that Mike can comment on? I'll open the floor. We don't have Ezekiel here today, who always has questions.
Well, I thought it was interesting when Nicole brought up. Sometimes you just think of things with when you're thinking to yourself, you got the blinders on, but a drought situation would be exactly what we're dealing with, right? So it's the same concept.
Yeah, and you do.
So
I mean, you are in a desert area. You have a great big lake, but you are actually in a desert area.
That's true. And I don't think the public would like us if we kept pumping it out of the lake and ran it through the sewer system. So I'm not quite sure how I would explain that one.
So any questions or thoughts from anybody?
A quick question. I know the Caribbean diet is very different to the Canadian diet, but one of the problems that we have in Barbados is fats, oils, and grease coming into the sewer system. What do you all encounter over there?
We definitely have some, not a huge problem at this time. We are very, the one picture I showed that had the staff component, our source control tech spends a lot of time being proactive and going to restaurants. There's making sure their grease traps are in place, that they're cleaned out properly, all that kind of stuff. And that has helped us limit the problems at the plant. Prior to having a source control tech, though, there was, we dealing with the same issues everybody else had with that stuff just piling up at the plant. We're a city of approximately 120, 130,000 people now. And I could use probably 2 or 3 source control techs just to be proactive running around. So one definitely isn't enough, but it helps keep things at bay.
And do you have regulations that are enforced?
We have bylaws. What I've found is we have more buy-in from the community if we use the carrot versus the stick approach. So if they're having a problem with one of their grease traps, we just run out there and write them up or do different things or send the bylaw group out. We try and work with them, help them contact a trucking company, to do their, to help them, or a vac truck company to help them clean things out and get it back into shape. We'll spend some more time to dropping off literature and trying to educate people as much as possible. If you think about it, for a restaurant owner, that's not what they do. That's like trying to talk to me, or if you want me to talk about everything they're doing on the water supply system, right? I have a concept, but that's not what I do every day. And the restaurant guys, they don't know anything about grease traps and how to maintain those. They do a really great job at serving you food, and so they need some help to get things done. And we've found, again, using the carrot method has been much more beneficial. They're more willing to spend some of their money to correct a problem if you work with them.
Yeah. Nicole, is it a big problem where you are?
Yes, but we are trying to help. As Mike says, what I would have found when I was there is that they didn't know how much it impacted the sewer system. And so it was just a matter of educating and trying to get them part of their maintenance, because they have the other maintenance and the and sanitation needs that they have to do to make sure that they remain open as a restaurant. But the grease trap cleaning and stuff was not, key on that initially. So we're working to make sure that it is there, as much as getting rid of your bin refuse to stop cockroaches and rats from coming in. So hopefully we'll continue on that thread, and it will no longer be a big problem as it has been.
Nice.
What about in some of the other countries? What are some of the issues that you're facing? Are you facing contaminant issues? Maybe they have no problems, which I don't believe. Mike, what are your issues right now with things like contaminants? I mean, I think pharmaceuticals has been a big thing. We've had a lot of lead situations. What has affected you?
Yeah, pharmaceuticals are on our radar for sure. We are part of a nationwide program that does wastewater sampling annually. Takes a good, gathers information from across the country, and then puts that into a format and shares that report with everyone. We do not have any regulations at this point in time to require us to deal with pharmaceuticals, but we're trying to make sure that we educate ourselves and at least have a game plan, because sooner or later it's going to happen and they're going to say, well, you need to treat pharmaceuticals before they go into our lake discharge, which is everybody uses for their drinking water and their source of recreation.
Right. Okay. I'm not seeing any other questions. Because we had a couple of people come late, maybe Mike, you could just play the video that you played at the beginning one more time for those people, just to give them an idea of what your plant looks like. And as I say, when you look at it again, or you see it for the first time, you'll notice how everything looks brand spanking new. And that's not the case as we talked about. It is because of the operations and maintenance and just the cleaning programs. You see the guys cleaning everything. And so when you walk into many plants in Canada, they look like they are absolutely brand new, and they're many, many years old and the equipment's old, but it's just how it's kept. And this is what we are trying to encourage in the Caribbean, is a much more robust operations and maintenance. So maybe if nobody has any other questions, if you do have a question, put it in the chat, but otherwise maybe we'll just play that video one more time. And
why don't I play the other video? It's a 3-minute video. It covers a lot of the same stuff, but at least that way it's not a repeat for everyone.
Okay.
Okay, I'll do that. Bear with me. You should have it now.
The City of Kelowna has a vision of being the best mid-sized city in North America, and we are becoming that each day by leading the development of a safe, vibrant, and sustainable city.
For the highly trained technical staff working at the wastewater treatment facility, this means using cost-effective and environmentally sound practices to treat water coming out of our homes and businesses before pumping it into Okanagan Lake. Located in the Pandosy area, the wastewater treatment facility services close to 80% of the city's population, but we still have room to meet the needs of our growing community beyond 2030. Since the facility opened in the early 1900s, the city has led the way in sustainable waste management practices through a few key upgrades. In 1982, the plant was upgraded to accommodate the Barton flow process. This chemical-free process removes biological nutrients from the wastewater before it is pumped back into the lake. Our facility was the first in North America to accommodate this process. More recently, the facility has been upgraded to include an odor control system, which has nearly eliminated any unpleasant odor from the air, which is important for our crews and our neighbors. The upgrade also increased our ability to meet the needs of the city, as we can now treat up to 70 million liters a day. That is about 28 Olympic-sized pools. But how does the system work? Wastewater is the water that leaves our homes and businesses from taps, tubs, and toilets. To prevent this water from harming the environment or our health, it is carried to the wastewater treatment facility by 500 kilometers of underground pipe. Just before entering the facility, the wastewater is screened to remove large and small inorganic materials. Using state-of-the-art technologies, dirt removers and primary clarifiers remove additional materials. Matter collected in the primary clarifiers is pumped to the fermenters before being combined with matter from the bioreactor. This is then composted with wood chips and sold as overgrow, an excellent fertilizer that is available to residents and businesses. After the wastewater makes it through the secondary clarifiers and UV disinfection, it is pumped into Okanagan Lake at a depth of more than 65 meters. At this point, the water is nearly drinking water quality, which is a good thing since the lake is our main drinking water source. As the city looks at ways to improve our process and protect our main water source, the community can also do a lot to reduce the demand on our system. For example, don't flush grease, oil, or expired medication down the drain. Install low flow fixtures, and turn off the tap when you're brushing your teeth or shaving.
I always find it interesting with those videos because it's a few years old, but it's still accurate for sure. But I didn't have any gray hair then, and I do now.
Okay, so I don't see any questions. So Mike, thank you very much for the time. Thank you everybody for your patience with the technical glitches. I hope you've got anything. Mike is always there. I think he knows many of you from the wastewater courses, and we are going to be doing more wastewater exam treatment for both treatment and collection courses in some of the countries in the fall and spring. So look, if anybody hasn't done their level 1 or 2 and is looking for that, we're going to be doing more courses. So Mike, thank you very much, and I won't be seeing you for a little while. I head to Europe right now. I'm working on the situation in Ukraine and helping rebuild some of the Ukrainian water and wastewater facilities that have been bombed in the war there. So I'm heading to Europe. I definitely won't be here next week. I'll be in the air, but I'm gone for 2.5 months. But I will be calling in sometimes as I'm able to. So I look forward to seeing you all again very soon. And it's been always great to see everybody. And thank you, Mike, for your time.
You're welcome, and thank you, everybody, and thank you for the conversation. I always enjoy the brainstorming, so I appreciate it. Have a great evening.
Okay, thank you. I just
Thanks. Travel safely, Valerie.
Thank you.
Travel safely.
Bye, Mike. Keep it up.
I'll miss you all. Bye-bye.
Safe travels.
Bye. Hey, Mike, you still there? No.
Oh, I think he may have left off.
Okay, I'll send him an email.
Yeah, do you have his email?
I should, yes.
If not, get in touch with me and I can get it for you.
No problem. Thank you very much.